Algebra 2, quadratic equations, type 2 factorise. So type 1 we saw in class was our graphing, and looking at the graph where it cuts the x-axis are our roots of our equation. So here we're looking at factorising. So we had factorised in Algebra 1, so now we have to take it one step further, find our factors, let them equal to 0 and solve. So we treat it the same way as we did in Algebra 1, where we look at the coefficient of x squared and we multiply that by the constant, which is 18. So we have 2 times 18 equals 36. So we say what multiplies to give us this number 36 and adds to give us this middle number in front of x, which is minus 13. So if I look at the factors of 36, I know that 9 times 4 gives me 36, but 9 plus 4 gives me plus 13. So therefore it must be minus 9 and minus 4, because minus 9 times minus 4 is plus 36, and minus 9 minus 4 is minus 13x. So we take this middle number, minus 13x, and we replace it then with these two factors, minus 9 and minus 4. Everything else stays the same. So all I'm doing is I'm expanding that 13x. I'm splitting it into two numbers. So the 2x squared stays the same, and then minus 9x minus 4x is minus 13x. So I haven't actually changed the equation here, and therefore the plus 18 stays the same. So I've literally just, as I said, take that middle number and separate it out into the two factors. So we then group the first two, group the second two, and we take out the highest common factor. So the only thing common between 2x squared and minus 9x is x. So if I take out x, that leaves me with 2x minus 9. And then if I look at minus 4x and plus 18, well, the highest common factor is 2. So again, if I take out minus 2x, that leaves me with plus 2x minus 9 equals 0. So of course, if I took out plus 2x there, I'd end up with minus 2x plus 9 in the brackets, which wouldn't work. So we'd have to go back and change our sign. So what we want is basically these two brackets to be the same again, so I can take out the highest common factor. And if I take out the highest common factor, that leaves me with 2x minus 9 times x. Sorry, that shouldn't be a minus of 2x there. That should be minus 2. So if I take out the highest common factor, as I said, there we have 2x minus 9 times x minus 2 equals 0. So what this means is that both of these brackets multiply to give me 0. And the only way we can get two brackets multiplying to give me 0 is if the first bracket is 0, or if the second bracket is 0, or both are 0. So 0 times anything is 0. So therefore 2x minus 9 equals 0. Well, 2x equals 9, which means that x equals 9 over 2, or x minus 2 equals 0, so x equals 2. And therefore these are our roots of the equation. In other words, that would be where they would cut the x-axis if we were to sketch the graph of the quadratic. Now, if I just look back up here for a second where we had the minus 9 minus 4, when we replace the minus 13x with the minus 9x minus 4x, it doesn't matter which order we put them in. You could put in the minus 4x first and the minus 9x second, and you would still get exactly the same answer. So don't worry about the order, just make sure that you have the correct signs and that you're keeping the function exactly as it is, but you're only changing the middle number there. Okay, so type 3 then. So with type 3, it's the quadratic formula. So basically we can use this quadratic formula when 1, we can't factorise, 2, we're asked to write our answer in decimal form, so correct 2 or 3 decimal places, 3, asked to write our answer in surd form, so such as a plus root b over c, or plus or minus root b, I should say, over c, or all the time. So you can actually use this formula every single time you want to solve a quadratic. But more often than not, we always tend to factorise. So this formula can basically be found on page 20 in our maths tables. And we'll see that when we have a quadratic equation, ax squared plus bx plus c equals 0, a being the coefficient of x squared, b being the coefficient of x, and c being the constant, then if we want to solve this, we can say x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So in other words, all we do is we take the coefficient of x squared, the coefficient of x and the constant, and we sub it into our formula and then simplify. And always check our answer. Is it going to be written in surd form or is it going to be written in decimal form? So let's have a look at an example. So we're going to solve correct to 3 decimal places. And we're going to solve for 2x squared minus x minus 17 equals 0. So if we look, a is our coefficient of x squared, b is our coefficient of x, and c is our constant. So we then write out our formula, and we say x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And we sub in our values, so we get minus b, so be careful of the double negatives, plus or minus the square root of, using brackets, b squared minus 4 times a times c all over 2 times a. So we have minus 1 is going to be plus 1, and the square root of minus 1 squared minus 4 times 2 times minus 17 is 137. All over 2 times 2, which is 4. So what that basically means is that x must equal 1 plus square root of 137 over 4, or x is equal to 1 minus the square root of 137 over 4. So that would be our answer in surd form, because we cannot simplify the square root of 137, but the question has clearly stated that it wants our answer correct to 3 decimal places. So if we put that into our calculators, we then end up with 3.176, or x is equal to minus 2.676. So again, always checking the number after the third. If it's 5 or more, we round up the number. If it's less than 5, the number stays as it is. So let's look at one where we are going to do it in surd form. So example, we're going to solve 6x squared plus 8x plus 1 equals 0. And right answer in surd form. So surd form means we're going to leave our answer with a square root in it. So again, coefficient of x squared is 6, coefficient of x is 8, and constant is 1. So if we write out our formula, we have minus b plus or minus the square root of b squared minus 4ac all over 2a. And again, always writing out your formula before doing your substitution. So we have x is equal to minus b plus or minus the square root of brackets b squared minus 4 times a times c all over 2 times a. So that gives us x is equal to minus 8 plus or minus the square root of 40 all over 12. So we have to simplify our surd here. So I can simplify the square root of 40, because the square root of 40, if I look at the highest perfect square that divides into 40, I can see that 4 divides into 40. So therefore that would be the square root of 4 times the square root of 10. And of course the square root of 4 is 2. And of course if you put root 40 into your calculator and equals, it automatically simplifies your surd for you. So of course 2 will divide into the 8, 2 will divide into 2, and 2 will divide into 12. So if I divide the top and the bottom by 2, I end up with minus 4 plus root 10 over 6, or minus 4 minus root 10 over 6. And I cannot simplify that any further, because root 10 can't be simplified, and therefore there would be no other common factor between the top and the bottom. Okay, so let's look at type 4 next. So we basically want to take the quadratic first and solve as normal. So we have what multiplies to give us 56 and adds to give us our middle number there, which is minus 15. And if we look at factors of 56, we have 7 times 8. But 7 times 8 gives us 56, but 7 times 7 plus 8 gives us plus 15. So we need to change that to minus 7 and minus 8, because minus by minus gives us plus 56, and minus 7 minus 8 adds to give us minus 15x. So we're going to, again, expand that 15x into 7 and 8. And again, it doesn't matter which order we put in the 7 and the 8. So we have minus 7x minus 8x plus 56 equals 0. And if we group the first two and take out the highest common factor, then what we have is x is common between x squared and minus 7x. So that's x times minus 7. And 8 is common between 56 and 8. I'm going to take out minus 8, so that gives me x times minus 7 equals 0. Because again, we want these two brackets to be the same. In other words, we want to take out the highest common factor again. So if I take out x minus 7 as being common, that leaves me with x minus 8. So both of these brackets multiply to give me 0, which means x minus 7 equals 0, or x minus 8 equals 0, and therefore x must equal 7, or x must equal 8. So that's the first part of the question done. We have solved the quadratic. So the next part says hence, right? So it doesn't say hence or otherwise. Hence means we have to use what we have just solved. So what have we just solved? Well, we've just solved for x. Now, if we look closely at the second quadratic there, what you'll notice is that it's something squared minus 15 times something plus 56. So it's related to the first equation because that is also something squared minus 15 times something plus 56 equals 0. So let's make a note of that. So we say note 1. It says, so the question says hence. So we must use what we've got. From the first part. To solve, right? If it said otherwise, we could just multiply out the brackets and solve the quadratic. And if it said hence or otherwise, and that means you can solve by any method. Okay, so what we're going to do is we're going to compare the two equations to see if they're the same. So we would say they're similar or related. And then what we do is we basically let our roots equal what's in the brackets. So if we go back to that equation, you can see what's inside the bracket there. It's y plus 10 over y. So we're going to let y plus 10 over y equal our two values for x, which is 7 and 8. So therefore what that means is that we have y plus 10 over y equals 7, or y plus 10 over y equals 8. So we're going to solve two equations now. And of course we have fractions here, so our lowest common denominator is y. So if I multiply both sides across by y, I get y by y, which is y squared, y by 10 over y, which gives me 10y over y, in other words 10. And don't forget to multiply the right hand side by y, so I get 7y. So here we have a quadratic all in terms of y, in which we're going to solve. So we can see, well, what are the factors of 10 that add to give us 7? And it would be minus 5 and minus 2. So replacing minus 7y with 5y and 2y, and then group the first two, take out your highest common factor, and group the second two and take out your highest common factor. Well, I have y times y minus 5 minus 2 times y minus 5 equals 0. So if I take out the highest common factor a second time, I'm left with y minus 5 by y minus 2. And then if I let both of those brackets equal 0, I get y equals 5 or y equals 2. But of course, that's only one of the equations. We now have a second one to look at here on the right-hand side. So if I multiply both sides across by y again, I get y squared plus 10 equals 8y. So y squared minus 8y plus 10 equals 0. So what are the factors that multiply to give me 10 and add to give me 8? Is actually none this time. So here I have to use my quadratic formula to solve. So if I sub in, we have x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And that gives me 8 plus or minus the square root of, so 64 minus 40 is root 24 over 2. And if I simplify root 24, well, the highest perfect square that divides into that is 4. So that would be root 4 by root 6 over 2. So in other words, we have 8 plus or minus 2 root 6, and 2 divides into 8 4 times, and 2 divides into 2 once. So we're left with 4 plus or minus, and that should not say y, that should all say y, I should say there, sorry. My apologies. It's not x, it's y. So we have y equals y equals y, y, and y. So we end up with 4 solutions for y. So y equals 5, y equals 2, y equals 4 plus root 6, or y equals 4 minus root 6. Okay, so let's look at type 5. So type 5 is fractions, and we're asked to solve here correct to 2 decimal places. And the first thing I'm going to do is I'm going to put brackets around my denominators. And also, if we note, it says x cannot equal minus 1 or 3. So let's just see why is that, right? So if I look at x equals 1, or minus 1 I should say, then what we end up with is 1 over minus 1 plus 1 in the first denominator there, which is 1 over 0, and therefore undefined. And if x equals 3 in the second fraction, then we end up with the same situation where we get 3 minus 3, which is 1 over 0, and again, undefined. So therefore, we can't have those two values for this particular equation, because we end up with 2 cases where we have undefined. And also the second thing to note is when we're eliminating fractions to solve here, then we multiply across by the lowest common denominator. Okay, but we have to make sure we multiply both sides by the lowest common denominator. So our lowest common denominator here is x plus 1 by x minus 3. So that means I'm going to multiply everything across by x plus 1, x minus 3. So I'll get 1 times x plus 1, x minus 3, and that's over x plus 1. And then I multiply again 1 by x plus 1 by x minus 3, and that's all over x minus 3. And that equals 2 times x plus 1 by x minus 3. So you can see x plus 1 goes into x plus 1 once, and x minus 3 goes into x minus 3 once. So that gives me 1 times x minus 3, in other words x minus 3, 1 times x plus 1, which is x plus 1, and then we have 2 by x plus 1 by x minus 3. So let me just multiply out the 2 by x plus 1, which gives me 2x plus 2, and then I have to multiply that by x minus 3. So on the left-hand side, I have 2x minus 2, and on the right-hand side, I end up with 2x by x, which is 2x squared, 2x by minus 3, which is minus 6x, 2 by x, which is 2x, and 2 by minus 3, which is minus 6. So again, if I bring everything to one side, then what I end up with is on the right, minus 4x minus 6. and then I get 2x squared, subtract 2x from both sides, gives me minus 6x, add 2 to both sides, and I get minus 4 equals 0. I can simplify that by dividing everything across by 2. And now I'll look, and I can see that there's nothing that will multiply to give me minus 2 and add to give me 3. Now the hint was also that it says correct to 2 decimal places. That instantly implies that we're going to be using the quadratic formula. So you don't even need to waste time trying to see what are your factors of 2 that add to give you minus 3. So if I sub into my formula, x equals minus b plus or minus b squared minus 4ac all over 2a. Then that gives me x is equal to minus 3 plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'll go on to the next page there, and that gives us x equals 3 plus or minus the square root of, so we have 9 plus 8, which is root 17, all over 2. And corrected 2 decimal place then gives us 3.56 or minus 0.56. So there are 2 roots of our equations. So the last one then is type 6. So for type 6 we want to form a quadratic equation. So suppose we are given 2 roots. Let's say these roots are x equals 3 and x equals 6. Then the easy way of finding the quadratic equation is we can work backwards. So what I mean by working backwards is if we look, what we're given are the roots. So our roots are x equals 3 and x equals 6. So if I go back one step, what we have are the factors. And the factors are x minus 3 and x minus 6. So if I subtract 3 from both sides there and subtract 6 from both sides, and because they're factors, they should multiply to give me 0 because that's how we got roots in the first place. So therefore the quadratic then is very simply found by multiplying out your brackets. So we'd have x by x is x squared, x by minus 6 is minus 6x, minus 3 by x is minus 3x, and minus 3 by minus 6 is plus 18 equals 0. And if I take out x as being common then, and I get minus x as being common, then we have 6 plus 3 plus 18 equals 0. So we end up with x squared minus 9x plus 18 equals 0. So that's kind of the long way of getting your quadratic. But if we note, the coefficient of x is the sum of the roots. Because 3 and 6 were the roots, and if we add them, we get the coefficient of x there. And the constant is the product of the roots, because 6 times 3 is 18. So what we can actually say is we can have a very quick way of doing it is x squared minus x times the sum of the roots, and this works every single time, plus the product of the roots equals 0. But this is not in our maths tables, so we need to know that one off by heart. So if we were to do a quick version where we were given x equals 5 and x equals minus 7 are the roots, then I could just say x squared minus x times the sum of the roots, so 5 minus 7, so if I add them, plus the product of the roots, so 5 times minus 7 equals 0. And that gives me, well, 5 minus 7 is minus 2. Minus 2 times minus x is plus 2x. And 5 times minus 7 is minus 35 equals 0. So very, very quick, simple way of doing it. But if you forget the x squared minus x times the sum of the roots plus the product of the roots, you can go and write down roots, factors and multiply out. Okay?